What's the direction? What's the width? Exact same steps, even though it's a parabola. What is step number 1? Invariant points. So what I like to do when I have more than just a line is put your ruler on the x-axis. Anytime it crosses, you're going to mark those. So this time we have 2 invariant points at y equal to 0. Then move your ruler up to y equal to 1, mark wherever it crosses. So we have 2 invariant points at y equal to 1. So how many invariant points in total do we have? 4 of them this time. Step number 2. Anything underneath is gone. So what do you think the square root graph of this is going to look like? So this one is going this way, and this is going that way. Well, if we think of it in terms of line, this is like a negative slope. And if we think of this in terms of line, it's a positive slope. So what do you think is about to happen? 2 swoops. So this one's going to go towards the left. This one's going to go towards the right. So parabola ends up being a left and a right swoop. As long as you have 2 points marked, which are the invariant points, you're good to go. Okay, let's see what happens to the domain. So let's do the domain of the parabola. Anybody? 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 Bueller? Offer of negative infinity to infinity, agree? Okay, the range?
The domain would be negative infinity to -2.
We're doing the original.
Oh.
Because we're comparing. Okay, what's the range of the original? But there's a low point, right? There's nothing under here. I'm just waiting for someone to fix this. How do you write it, the other notation? X is, but this is y. Greater than or equal to -4. Okay, the new one. What do we do with the domain here? Well, we just do it in pieces. So let's just look at this piece first. So what would the domain of this piece be? So we have to go to the lowest first and the highest. And does it include -2? Does it cross through? Okay. And now let's just look at this piece. So ignore the other one. Just look at the right-hand side. 2 to infinity. And what symbol do we use in between? So you would have seen this last year. It's a U, but it doesn't have a tail on it. Okay, so let's talk about what this symbol means. It's called union. That's why it's a U. What does it mean mathematically? It just means and. So we're saying the domain is that part on the left and the part on the right. If we want to do with the other notation, we would say x is union x is, okay? The range. So let's just look at the left-hand side first. Well, what has the range been for every single other question? Okay, so negative infinity to 0 to infinity. Now what about on the right-hand side? Same thing, so do we need to write it twice? There's our range. Okay, so you might want to highlight that union symbol so you remember for the next questions, how do you do it when it's in pieces? Okay, let's do a couple more parabolas. Go ahead and sketch the parabola. So by yourself, with a friend, whatever you want. Okay, tell me how to draw it. Imagine I've never seen a parabola. Tell me how to draw this. Okay. Go down. Okay. What? Okay. Okay, so back at my point. Oh, you don't see my drawing. Very good. Back at my point, and then you said go down, so I went like that. Down to over 1, okay. Down to over 1, okay. Okay. Do it again. Oh, no, no. Yeah, okay, now what? How'd I do? Nice. Woohoo! Step number 1 for doing the radical. Invariant points. Where am I putting my ruler? What am I doing? What's going on now? Okay, so wherever the x-intercepts are. Why these points? Why are these so special? Okay, step number 2. Oh. Well, how is this different than the last example? It's going down, so suddenly now the points I don't want to look at are on the left and right. So no swoops with this one. What am I going to do? What am I going to do? Because these are going inward. They're not going outward before? Yeah, well, don't forget what the transformation is. What we're doing is the square root of every single y value. So let's go in the middle where I don't have a point yet. What's the square root of 9? So it goes down to 3. And you get the little hump. Okay, so there's what the square root looks like when it's a radical or a downward parabola. So we're just going to mark the 3 came from the square root of 9. Okay, just like the 4 would have gone down to 2. We just didn't choose those points. Okay, domain. Domain. Just to the radical, yeah.
It's going to be negative root 4.5
Where the heck did that come from?
I set y equal to 0.
Okay, so did this cross through even, nice, pretty points? No, so we can't estimate. We need to know the exact value. So how do I find the x-intercepts of this graph?
Set y equal to 0.
So go back to our parabola, and we're going to set y equal to 0. Okay, so all we're doing is finding the x-intercepts just like last year. Oop, forgot the negative on the 2. Okay, how do I solve this? So how do I get rid of a plus 9? Subtract 9.
Divide both sides by -4.5.
We wouldn't go decimal at this point. What do we normally do with fractions when we're solving equations? We just leave it, right? So 9 over 2. Ooh, and we put a square root into an equation. So I'm going to grab my red pen to remind us. Plus or minus has to be in front of it. Okay, what do I do with a square root in a crazy fraction like this? Square root what you can, leave what you can't. So can we do the square root of 9 evenly? Okay, so that's going to become, can we do the square root of 2 evenly? So it just stays. You can rationalize or not rationalize. Remember on the exam they don't make you, so it's totally up to you. And so what tells us is there it's crossing at negative 3 over root 2, and here it's crossing at positive 3 over root 2. Well, what does that do for the domain? Why does that help us? Well, what we need to say is all the points between. So how do we say between mathematically? That's and. Thing.
It would be negative 3 over root 2 is less than or equal to x is less than or equal to 3 over root 2.
There's how we say between. If you like the other notation, it would be? The voice is trailed off.
Negative 3 over root 2, comma 3 over root 2.
There you go. Okay, so you might want to make a note here. You have to solve for the x-intercepts when they're not exact numbers. Solve for the x-intercepts. The reason it's not good enough to guess is because on the exam they might give you, for example, a multiple choice and the answers look like this. And without a calculator, how are you going to figure out what numbers those are? So that's why you have to solve. We still need to do the range, so that was domain. No big surprise, what's the range? Well, you need to be a little careful with this one because it's not going up to infinity. So it starts at 0, but the maximum point is. So we get 0 less than equal to y less than equal to 3. So here's an example where it does change. And that will always be with a downward parabola. Okay, so we've done negative lines, we've done positive lines, we've done negative parabolas, positive parabola. Are you ready for one on your own? Okay, find a friend, try it. Some of you kind of need a hint to start. What's the problem with this? Can't use it. Yes, we need to change it into the right form. What do we call this process? Complete the square. High five to you. So let's review, how do we complete the square? We only did this like 500 times last year. Adding was 10 years ago and you still remember that. Okay, so with all of our brains, let's put it all together and see if together we can come up with the steps. Okay, so we do something with the 2. Okay, he says put it onto the side. Oh. Ooh, divide. And why do I subtract it over here? Okay, let's just pause. Okay, tell me again where this came from.
You did the 4x divided by 2 squared.
Middle divided by 2 squared, because that's called completing the square. And why did we have to subtract it?
Because you have added it in.
It's to balance the equation out. Okay, how do we finish it off?
X plus 2 squared.
Where did the 2 come from? Yep, b over 2 or the square root of the 4. And then we combine those two and we get? Is it all coming back now? Does that help to draw the parabola? Okay. Okay, let's just do this together. So tell me, how do I draw the parabola? Yes, what's my vertex? I agree. Okay. Why am I going up? And then over up 3, over up 5. So you have 2 choices for the square root of a parabola. It's either going to be double swoop or it's going to be little tiny mountain or hill. Is this a double swoop or is it mountain or hill? How do we know it's a double swoop? Because it's going up. So we can ignore stuff here. What are my special points we're going to mark? And the left-hand side is going to swoop. And the right-hand side is going to swoop to the right. Okay, it's the only 2 choices is double swoop or little mountain. domain and range. What do we need to find before we can find the domain?
The x-intercept.
Okay, how do we find the x-intercepts? Okay, do you want to do from the original form or from completed the square form? Okay. Okay, so let's go through the steps together. What am I going to move first? Okay.
Square root of both sides.
And
Plus or minus on 2.
okay, so we get plus or minus root 2 equals
X plus 2.
x plus 2.
And subtract 2 from both sides.
And remember, we stick it in front of that root. So that means the one on the left is the negative 2 minus root 2 and negative 2 plus root 2. Okie doke, domain. So let's just do the left swoop first. Left swoop. Okay, if you want interval notation, it would be negative infinity to negative 2 minus root 2. Okay, how do we do the right swoop? Okay, x is greater than or equal to. And what do I need to put in between them to say and? Union. Range.
Sorry for the interruption. All grade 10 students with the last name beginning with the letter A through to the letter H. If you have not received your pictures yet for this school year or need to get picture retakes done, if you can please make your way to the gym, the upper level in the mezzanine. Thank you.
We're good with the range? Why did we have 2 pieces to the domain, but we only have 1 piece to the range? Because the 2 pieces have the exact same range, so we will need to write it once. Okay, so we've done positive lines, negative lines, positive parabolas, negative parabolas. The last one we're going to do, oh, what is this? What kind of graph? Cubic. Cubic. Okay, what do we do with a cubic? Yes, mark the invariant points. Where are the invariant points? So all of the x-intercepts, and there's how many x-intercepts? 3. And the other invariant point? Y equal to 1, and how many invariant points do we have there? 1. Okay, so steps haven't changed even though it's a cubic. What's the second step? Anything underneath, bye-bye. So what we end up having here between these two is just a little tiny hill. Well, where have we seen something like that before? Sort of all the graphs we just did, which one looked like that, just bigger? The negative parabola looked exactly the same. And how did we do the square root of the negative parabola? So the big hill went to the little hill. So all we need to do is take the square root of that middle value. Well, what the heck is that middle value? So all we know is it's going to get smaller, so this is going to be a little tiny hill now. It's so small you can't even see it. It's just a little tiny hill. Okay, let's look at this section. Well, we've seen this before. Where did we see something that looked like this? With the positive parabola. And how did we do the square root of the positive parabola? People are like this. Yes, swoop to the right. There you go.
Thompson, wouldn't the first little bump go up, like go higher than it?
If you take the square root, it's going to go smaller.
But it's less than 1. Like the square root of a half is 0.7.
Yeah, you're right. You're right. It is going to go a little bit up. He's right. Thanks, Kelsey. Well, it'll be right close to it. Again, we're not going to measure on the exam. We just want to know, do you know what the shape looks like? Oh, God, the domain. Hardest part of these is not drawing. It's figuring out the domain. So again, let's do the pieces. So let's just look at this little guy first. Well, do we have nice x-intercepts, or do we need to calculate them? Well, we don't even have the equation, so that's probably an indication they're really nice values. Okay, so how do we say the little bump in between something and something? Okay, so the lowest is 4 would be way over here. What's the smallest x value? -1. Or if you're using the other notation, you would use -1 to 0. Okay, now we're just going to look at the swoop.